All right, welcome back. Hononegah Honors, Algebra 2. Section 4.1 is dealing with graphing polynomial functions, and you are going to want to or need a graphing calculator today. So I'll have to toggle back and forth as we get to the graphing calculator questions to a graphing calculator. But here we go. A binomial is a number, a variable, or the product of a number of one or more variables. Basically, what you're talking about is a single term. So you're talking about a situation in which a binomial would be example like 3 would be like 3x or 7x to the third power. And so when you start adding and subtracting binomials together, then this is referred to as a polynomial. So the polynomial is a binomial or the sum of binomials. So a polynomial function is a function of the form, and obviously you're not going to deal with too many functions that are quite this big, but ultimately a function in which you are going to write in what's called descending order. And we'll talk about that in a second. The exponents are always whole numbers. So the whole numbers are numbers starting with 1. And so 1, 2, 3, 4, 5. So no negative numbers. And the coefficients are real numbers. So no imaginary numbers are allowed in this. For this function, a sub n is the lead coefficient. N is the degree, and a sub 0 is the constant term. So now let's talk a little bit about that. So a standard form polynomial goes in descending order. So highest to lowest. So I'm going to write an example. F of x equals 7x to the fifth, 6x to the third, minus 5x to the second, plus 2x, minus 8. That would be an example of a polynomial function. The lead coefficient, the number in front of the highest exponent, that is your lead coefficient. So in this case, the lead coefficient is 7. That matters. It helps us get end behavior. It helps us direction. So again, the lead coefficient is very important because if it's positive, it goes one way. If it's negative, it goes another, just like a parabola. So if it's positive, it goes upward, and a negative, it goes downward. Now, the degree is the highest power, or the highest, so you take, in this case, x to the fifth. So the degree, I don't know why I put an n, the degree is 5. Okay? And then the last one, although it really doesn't make a whole lot of difference, but this one is considered the constant. It's the number that does not have a variable. The constant is actually always the y-intercept. So that is one thing that it does give you. All right, so here we go. Lead coefficient, degree, and constant. I'm going to look at, so if I was going to some common polynomial functions, if you have a degree of 0, basically meaning there's no variable, okay, that is called a constant. If you have a degree of 1, that's called linear. If you have a degree of 2, that's called a quadratic. If you have a degree of 3, that's called a cubic. And if you have a degree of 4, it's a quartic. We will be graphing some things that are over 4, but quartic is about as big as we get with our graphs. So constant, linear, quadratic, cubic, and quartic. So if I was going to classify these polynomials, decide whether the function is a polynomial or not. If so, put it in standard form, state the degree, the type, and the lead coefficient. So lots of questions here. So I am looking basically at the exponents, and I see x to the first, x to the second, and x to the 0. So this is a polynomial. Write it in descending order, meaning the highest degree comes first, the next highest degree comes second, and so on. So here is, so I'm looking at the exponents and deciding there's the function. So now, that's standard form. The degree in this case is 2, because that is the highest exponent. The lead coefficient is 7. And then the type, because it is a 2 degree, this would be a quadratic function. Next one, because you have something that's a negative exponent, this is not a polynomial. Now the next one's going to confuse some people. It actually is a polynomial. The fact that you have an irrational value doesn't make any difference. So I'm going to put this in descending order. So the highest exponent to the lowest exponent. And then I'm going to answer the 3 questions: degree, lead coefficient, and type. So the degree in this case is 4. The lead coefficient is the square root of 3. And because you have a 4th degree, that's called a quartic. So on your test and on your quiz, this will probably be the first question. So put it in standard form. State the degree, the lead coefficient, and the type. Next, actually doing some evaluating. There's actually a couple of different ways to do this, and right now we're going to learn one of them. Anytime I'm telling you what the x value would be, then I want you to put that in place of all the x's. So f of 4 would equal -2 times 4 to the 4th, 6 times 4 to the 3rd, minus 3 times 4, plus 11. So we're going to pull out a calculator here. And we're going to go 4 to the 4th power, which is 64. Whoops, sorry, not 64. 256. Plus 6 times 64, minus 3 times 4, plus 11. So I turn my calculator on. Here we go. -2 times 256, plus 6 times 64, minus 3 times 4, plus 11. I get -129. So you're evaluating when the x is 4, I get -129. Next one. End behavior of the function graph is behavior of the graph as x approaches positive infinity or negative infinity. For the graph of a polynomial function, the end behavior is determined by the function's degree and the sign of the lead coefficient. So now, and I know I'm going to put this on the next page. So here we go. If you have an odd degree, meaning x to the 1st, x to the 3rd, x to the 5th, x to the 7th, then the end behaviors will go in opposite directions. So if you have an odd and the lead coefficient is positive, then it's going to go upward from left to right. If you have an odd and the degree is negative, it's going downward from left to right. Now, I really want to talk about the other part in each of these pictures. You will notice, okay, the f of x and the x, okay, the as x, okay, so it should say as x, all right, sorry for the interruption, as x goes to positive infinity, f of x goes to blank. As x goes to negative infinity, f of x goes to blank. So now you have to fill in the blank. Here's what the blank says. As the x values go to positive infinity. So again, positive infinity is always on the right-hand side of the graph. As the x values go to positive infinity, the f of x values are either going to go up or down. You don't get to write up or down. But if it goes upward, you would put positive infinity. If it's going downward, you would put negative infinity. So again, depending on your picture, as depending on how you're going to fill in that blank. So I want to give a better explanation on that. So I'm just going to put a blank and we're going to talk about it again. So let's say I had a picture that did this. So that's a odd and it's got a negative lead coefficient. Okay, so it goes upward on one direction, downward on the other direction. So it goes in opposite directions, and I know it's got a negative lead coefficient. With that being said, as x goes to negative infinity, f of x goes to blank. As x goes to positive infinity, f of x goes to blank. So that's what it's going to look like on your test. So you'll notice on the negative infinity side, which this is the negative infinity side, it's going upwards. You'd put positive infinity. As x, this is the positive infinity side. And so as you can tell, this one's going downward, so you would say negative infinity. So let's go back now. Let's talk about evens. If it's even, such as x squared, x to the 4th, x to the 6th, you will notice that both of them go in the same direction. So they're both going upward if it's positive. If it's even and negative, they're both going downward. So now I'm going to put a blank one out here and we're going to talk about it one more time. So I've got a downward, which both of them are going down. So I know this is even. It's got a negative lead coefficient. With that being said, as x goes to negative infinity, f of x goes to blank. As x goes to positive infinity, f of x goes to blank. So now, this is the negative infinity side. It's going down. Here's the positive infinity side. It's also going down. So if you have an even, both of them are going to go in the same direction. Describe the end behavior. So just looking at this, I have an odd degree and I have a negative lead coefficient. So just knowing that it's an odd with a negative lead coefficient, I know what the picture is going to look like. With that being said, as x goes to negative infinity, f of x goes to blank. As x goes to positive infinity, f of x goes to blank. So now, on the left-hand side, the negative infinity side, I would say this one's going up. On the positive infinity side, I would say that one's going down. And this would be your answer. Graphing polynomials. This is where the graphing calculator. To graph a polynomial function, first plot the points to determine the shape of the graph, middle portion. Then connect the points with a smooth continuous curve and use what you know about end behaviors to actually sketch the picture. All right, you can do this the old-fashioned way. Like you could go ahead and just go start putting in values for x. So you could do an XY chart. There is nothing wrong with actually making an XY chart. With that being said, most of you will probably do a graphing calculator. So I'm going to pull up a graphing calculator here. All right, so now go to y equals, and we're going to type this in. So I believe it was x raised to the third. Now, if you have a newer calculator, you're going to have to hit the right arrow to get out of being up in the exponents, plus x squared minus 4, minus 4x plus 2. So I went ahead and typed in the graphing calculator of the function. Now I'm going to hit graph. And there it is. And so I actually want these points now on, so I want to go to my table function, and I want to actually then plot these points. So I'm going to go back over here to my graph, and I'm going to plot those points. So I have the points such as, so I'm going to write these down. So I have points like -3, -4, or -2, 6, and -1, 6, and 0, 2, and 1, 0. 2, 6, 3, 26. So again, that goes off the graph. And -4 goes off the graph. I believe it's -430. So here we go. I'm going to plot as many points as I can possibly plot. So -430 goes off. -3, -4, I can do that one. -2, +6. I can do that one. -1 also gets me 6. 0, 2, 1, 0, 2, back to 6 again, and 3 goes off the graph. So it goes up, it goes down, and it goes up. Is that consistent with what we would think? The degree is odd. Okay, that means it's going in opposite directions. It's a positive lead coefficient. Yes, it's going upward from left to right. So that's what they asked for in the last slide. It said, you know, with your understanding of end behavior, make sure the graph looks correct. Next one. Again, I'm going to go back to my graphing calculator, and I'm going to type this in. -x raised to the fourth minus x raised to the third plus 2x squared minus x minus 3. So I'm going to go to my graphing calculator, and I'm going to type that in. So sorry about that, but I'm going to do this again. So -x raised to the fourth minus x raised to the third plus 2x squared minus x minus 3. Graph. I apologize. I hit pause there for a second. I noticed that I did not put in a plus sign. So I'm going to have to sit here and try to fix this. Oops. Go back. And I want to insert a plus sign. There we go. So now my graph's going to look a little better. So it goes up and then it goes down. So now I want to hit second table and I want these points. So I'm going to go back over to my previous screen and I'm going to write down the points that I see here. So I'm going to write down the points for an XY chart. -3 goes off the graph. -2, -1, -1, 0, 0, -3, 1, -4, 2, -21. So plotting those points as best I can. -3 goes off the graph. -2, -1. -1, 0. 0, -3. 1, -4. And then the next one goes up. It goes down. It kind of zigzags here. And then it goes down again. Is that consistent with what we would talk about before with end behavior? It's got an even degree. And the lead coefficient is negative. Again, both the end behaviors are going downward. So yes, that is consistent with what we would have seen with an even degree with a lead coefficient that's negative. Now, this one is complicated. I'm not going to lie. And it's on your quiz, and I believe it's on your test. I'm not sure, but there's a lot of people that will struggle with this one. So I'm going to make myself a little sketch. I'm pretty sure there is something on your paper, but I'm not 100% sure there. All right, here we go. F is increasing when -2 to 3. F is decreasing from -2 to 3. F of x is greater than 0 when x is less than -4, and from 0 to 5. And f of x is less than 0 from between -4 and 0, and x is greater than 5. These are the two that you have to look at. That's the ones that were actually going to help you the most, okay? Look at, it says x is less than -4. So I'm going to put a dot at -4 on the graph. And then I'm going to put a dot at 0, and I'm going to put a dot at 5. So this line right here, okay? And what that is telling me is it's above the x-axis when it's less than -4. So this direction, it's above the x-axis. Then it's above the x-axis between these two. And I shouldn't have made that curve already. Let me try that again. It's above the x-axis between these two. Okay? And then the next one, it's below the x-axis when it's between -4 and 0. So I'm going to make it between -4 and 0. And it's also less than when it's greater than 5. And so what this has created is a graph. Okay? Now, let's talk about increasing and decreasing here. Okay? So from -2, which is right here, to 3, which is right here. Notice that the graph is going upward. It's decreasing. So this side would be decreasing, this side would be increasing, and this side is back to decreasing again. Use the graph to describe the degree and the lead coefficient. So the degree, I would accept if you said cubic or cubed, but it's actually just odd. Like I know for sure that it's an odd one because the left's going up and the right's going down. Lead coefficient and the lead coefficient would have to be negative. Because again, it's going downward from left to right. This is very complicated. Some of you are going to need to watch this video again, and hopefully you'll be able to understand it. Last but not least, estimate a population. People living in a city are modeled by the population of PT equals 1.2 t cubed minus 2t squared plus 15.7 t plus 3.8. So I would pull out your graphing calculator and go ahead and type that in. Minus, and don't worry about the t's, just use x's, that's okay. X plus 3.8. So I went ahead and typed it into my calculator, where t represents the year with t equals 1 corresponding to 2001. Use a graphing calculator to model the function for the intervals 1 to 10 and describe the behavior of the graph on this interval. So let's go back to our graphing calculator and let's type this in. So go to y equals, clear out what you have, and let's type this in. So I had 1.2 x raised to the third minus 2 x to the second plus 15.7 x plus 3.8. So I'm going to go back just to make sure that I typed it in right. So, all right, I believe I did. So now I want to graph this. And you're going to notice, wait a minute, I don't see much of this graph. Like, I don't see a lot of the stuff that I want to see. So I'm going to change my window. And I want to change the y maximum because it looks like it goes way up there. So I'm going to go down to y max. And let's put it way up there. Let's go like 500. Let's just see what happens. And hit graph. All right. So I'm seeing a pretty distinct curve then in that. So when I look at my table, at 0, it's 3.8. But at 10, it's all the way up to 1,160.8. So again, I couldn't even get it all the way in my picture, even putting it up to what I did. So describe the behavior of the graph on this interval. Would you say it's increasing or would you say it's decreasing? Well, it's definitely increasing, as I said. And I would do the extremes. So at 1, it is 18.7. And at 10, it's at 1160.8. What is the average rate of change? Now, anytime you're talking about a rate of change, you're talking about slope. So I'm going to take 1160.8 minus 18.7, 10 minus 1. So now 1160 minus 18.7, and then 10 minus 1. I'm going to get 126.81. What does that mean? Meaning each year, on average, it goes up 126.81 thousand. Remember, this is all in thousands. People. Now, is this sustainable? Meaning, is a population really going to do this? Hey, do you think this model can be used for years before 2001 or the years after 2010? No. There is no way that a population continues to increase at that rate. So there's logistics involved. Like sometimes you can't use a model. Let's say you get a model, but again, it's not going to be realistic at this rate. All right, so your homework assignment, this one's going to be a little bit tougher one, so make sure you're asking questions if you need to. It's on page 162, 3 through 21 odd, 25 to 39 odd, and then number 42. If you have any questions, make sure you talk to your teacher, and good luck.